All right, this is kind of take two with this video since the sound some of you said was really bad last night. You couldn't hear it. So I'm just going to re-record it. Let's hope the sound's better today. So today we're going to start our new unit on systems of equations, and we're going to learn how to solve systems first by graphing today. We're going to learn what a system actually is, how we find the solution, and how we solve by graphing. So a system of equations is just two or more equations taken together. Okay. A solution to one is just a point or an ordered pair, and for it to work, it's got to be true, the ordered pair, for all equations that are involved. And when we're solving, the solution is just going to be an ordered pair. Okay, so it's where the lines intersect, and it's an ordered pair. But first, let's talk about checking to see if something is a solution to a system. Okay, so is the point 2,5 a solution to the following system? My system is that y equals 2x plus 1 and the y equals 3x minus 1. Sometimes you see it written with a brace, sometimes you don't. So in order to check to see if this is a solution, this point has to lie on both lines, or it has to work in both systems. So I'm going to, remember, my 2 is my x, my 5 is my y, and I'm just going to sub it in. So for the first equation, I'm going to put 5 in for y, 2 in for x, and I'm going to simplify. I want my right side to be the same as my left, because remember, that tells me it's a true statement, and that's true. 5 does equal 5, so we know that it works. If I plug it into the second equation, the y equals 3x minus 1, I'm going to put the 5 in for the y, the 2 in for the x, and simplify. So 3 times 2 is 6, and 6 minus 1 is absolutely 5. So we know that that is the solution, or a solution. Okay. What does it look like if it's not a solution? So let's pick the point 3,7, let's say. And let's go ahead and sub it into the first equation. So the 3 is my x, the 7 is my y. So 7 equals 2 times 3 plus 1. 2 times 3 is 6, and 6 plus 1 is definitely 7, so that works. It's not, however, good enough to check that first equation. You've got to check the second one as well. So if I put it into my second equation, 7 equals 3 times 3 minus 1. 9 minus 1 is 8, so it doesn't work. 7 does not equal 8, so that's why that is not part of the solution set, or a solution. So the first thing we're going to do is learn how to solve these graphically. You should know how to graph. We spent a lot of time graphing, so I'm not going to spend a lot of time on how do you graph. Remember, though, this first equation, we have our superhero, the invisible one that comes down and puts ones in front of the x's to help us out, to help us think. So my first equation, my slope is 1, or 1 over 1, and my y-intercept is 3. So I'm going to go up to 3, and using the slope, going up 1 over 1 or down 1 and to the left 1, I've got this line right here. Now with the systems, the more points you graph, so a lot of times it's easier to find your intersection. So my second equation, the y equals 4x, remember that that can be rewritten as y equals 4x plus 0. So my slope is 4, or 4 over 1, and my y-intercept is 0. So I'm going to go to 0. The rise is 4, and the run is 1. So even if I just go up 4 and over 1, I've already found my solution. It's where these lines intersect. It's right there. And it is the point 1, 4. So the ordered pair 1, 4 is a solution to that system. Make sure that when you're talking about an ordered pair, that you put parentheses around the answers, or it's not an ordered pair. All right, next example. All right, In equation 1, my slope is -1/2. My y-intercept is 2 or 0, 2. So I'm going to go up to the 2. I'm going to go down 1 to the right 2. So my line falls. And here is that graph. It's hard to draw a straight line sometimes. Okay, my second line, and it helps also if you label, so if you make mistakes, we can easily go back and find your mistake. Of course, you guys will never make any mistakes. Okay, the second line, my slope is -3 or -3/1, and my y-intercept is 0, -3. So I'm going to go down to 0 and -3 to start. Then I'm going to go up 3, and then I have to go in the negative direction or to the left 1. Up 3 and to the left 1. So when I graph that, I can clearly see that they intersect at the point -2, +3. Next, we're going to graph both of these. The first, my slope is 3, my y-intercept is 2. So I'm going to go up to 2, and then up 3/1. If I go down in the negative direction because it's positive, I've got to go back in the negative direction. So here is my line for that. For my second equation, my slope is 3, my y-intercept is -2. Okay, so I'm going to go up 3 and over 1 and graph that. Didn't quite hit the lines there. What you are going to notice is that these lines are parallel, so they appear never ever to intersect, or they appear never to ever intersect. They're parallel. That's going to make sense because when we talked about writing equations, we said that parallel lines have the same slope, and these have that same slope. So we say that this is no solution. Those are parallel lines. They're never going to intersect, so it's no solution. All right. This example here, in equation 1, my slope is 1/5. My y-intercept is 5. So I'm going to go up to 5, plot a point, go +1, +5, -1, -5. So here is my line. My second equation, we need to solve for y, so we're just going to divide everything by 5. And I'm going to get y equals 1/5 x plus 5. Well, that is the same as my first equation, so obviously they're going to graph the same line. When that happens, we say that there are infinitely many solutions. We can't say that it's all real numbers because the numbers have to be paired together. So I can't say my solution is, say, 1 and 1, because that would be all real numbers, and it's not on that graph. So you need to make sure that your numbers are on your graph. Okay, so we say infinitely many solutions. All right. So our vocabulary, it's not on your notes, but we talk about inconsistent, consistent, independent, and dependent. An inconsistent equation is an equation that's never going to intersect. It's no solution. Okay, so this would be a parallel line. There are two parallel lines. Consistent means that they have a solution. Okay, if it's independent, it means it has one solution. If it's dependent, it means it has infinitely many solutions. So hopefully today that you learned that a system of equations is a set of ordered pairs taken together. Their solutions are ordered pairs, and we can solve them by graphing, and that point would be an intersection. Have a great night.